So we have been working with right triangles, and we've covered a bunch of different topics. If you were to go to our Canvas page for this unit, you can see all the different topics we've covered this unit. Remember, we started with the Pythagorean Theorem, and so that meant we knew we had to do simplifying radicals. And so we worked on radicals. We worked on special right triangles, 30, 60, 90, and 45, 45, 90. Then we got into the geometric mean and what happens if you drop an altitude from the right angle in a right triangle. It makes three similar right triangles. We talked about how the geometric mean could solve those missing parts. We got into trig to do so, ka, and toa. Did a little more practice with that with angles of elevation and angles of depression. And then we got into inverse trig to be able to find the measure of an angle using trig in right triangles. And then we showed that we could do some things with non-right triangles to find missing parts using law of sines and law of cosines. Does that ring any bells? It's what we've been doing. We had talked about having the test this week. I think we should probably push the test off to next week and spend this week reviewing. There's kind of a lot of content. So today is the first day of that. This is a review document. I want you to do this review. Please, please, please use separate paper. Do not try to squeeze it all on here. It won't fit. And then you'll be truncating your work so much that it won't make sense. You will only get full credit on this work if you do it on separate paper. If you try to squeeze it on here, you will not get full credit. There's a couple things I want to show you for this today in general. This stuff is so, ka, and toa. You might remember that we did things like this where we established relative to this angle. If we're looking for t, that's the opposite. We're given the hypotenuse, so I'd use so. That means sine of the angle is equal to the t over 18, excuse me, cross multiply and solve. For number 4, 5, and 6, it's asking us to do two things. It's saying verify that the lengths form a triangle, and then is the triangle acute, right, or obtuse? You may remember that we talked about establishing if it's a triangle by adding the two smaller sides together and making sure it's greater than the longest side. If in fact the sum of these two is greater than the longer side, then we're not stuck with one of these positions where these two legs are not long enough. So since this is greater than 34, we can say, yes, it's a triangle. That takes care of the first part. The second part then says, what we need to do is take the three sides and see if they fit for a right triangle. In other words, make sure that you can take the square root of 64, 67 approximately, it's about 8. So that means 9 is the biggest side. 4 squared plus square root of 67 squared equals 9 squared. And when you see that they don't match up, it's not 83 equals 83 to make it a right triangle, you know it's either acute or obtuse. You can either memorize the formulas that we wrote into our notes, or you can say, you look at the hypotenuse. And if the hypotenuse is not a right triangle and instead it's a little bit short, like this one is, that means that it's bending in a little bit. Instead of a full right triangle, it's an acute triangle. For number 7, 8, and 9, it's asking you to solve the triangle. What that means is you need to put together A, B, C for the angles, and little a, little b, and little c for the sides, and fill in all 6 of them. That's what it means for a triangle to be solved. So in number 7, you'll do the Pythagorean Theorem to find the missing side. And then you'll say the sine of one of the angles, I chose A, would be 5 over root 146. This is my variable now. I've got the sine of x basically. So I could take the inverse sine of both sides to get the measure of the angle equals the inverse sine of 5 over root 146. Plug it into my calculator and I get the value of one of the angles. And then I could subtract from 1 of 90 to get the other angle, because these two are always complementary, of course. And that fills this in for me. Number 13 is an interesting question. It asks you to write cosine in terms of sine. So let's say that I've got an angle here of 53 degrees. And I'm trying to write the cosine of 53 as the sine of something. The sine of what? So if this is 53, let's call this side A, B, and C. The sine of 53 is what over what? Ka. No. It'd be B over C, right? It's the adjacent over the hypotenuse. So the cosine of this would be B over C. What we're asking about is the sine of what angle would be that same B over C. What if we were looking at this angle? What if this were our eyeball? Would the sine of this be B over C? It would, wouldn't it? Do we know how to find this angle measure? So in other words, it turns out that in every single triangle, if you have the cosine of X, that's going to be equal to the sine of what? (90 minus X). In other words, the sine of this angle is equal to the cosine of the coangle, the other one in the right triangle. So that's a formula that I had not expressed to you before. 14, 15, and 16 you should be fine with. 17 also asks for a new formula. It's just a plug and chug formula. So I'm just going to derive it for you quickly. What it says is find the area of a triangle that's not a right triangle. So if this is 57 and this is 9 and this is 5, how could we possibly find the area of that triangle? Well, let's take a generalized moment here and say, if this is A, B, and C, do you remember how we label them? What should I call the side opposite angle A? Yeah, lowercase a, and opposite B, yep, and C. And so if I wanted to find the area of this shape, you know this from whatever it is, 5th grade or 3rd grade or something. What's the area of a triangle formula? 1/2 base times height. What do I put as my height? Wouldn't be C or A, would it? Because it has to be perpendicular to this base. So if we're saying 1/2 this base, we'd need to have whatever it is that comes down like this, and that would be our height. So the area would be 1/2 base times height. But if we didn't have this, we could use sine. What would the sine of S of A be? Good. It would be the opposite side over the hypotenuse. So it'd be H over C, which means I could cross multiply and get that H is equal to C times sine of A. If I take that, which is equal to H, and plug it in up here, I get a formula that says the area of a triangle, ABC, is equal to 1/2 B times C times sine of A. In other words, it doesn't matter which letters are labeled which, but if you're in this position, side angle side, where it's trapped in between, then the area of the triangle would be 1/2 9 times 5 times the sine of 57. And you can just plug that into a calculator and crank that out. Everything else on this review should be familiar to you. If it's not, it's because you've forgotten a little bit, and that's okay. That's why we're taking a week to do this review, recover from a week of spring break that I hope was able to replace your brain with some things other than geometry. This is your homework for today. We've got the rest of the period. I've also recorded this now, so I'm going to post this up right now if you want to go back and see the things I just did more slowly.